Hello, today we will be starting metallurgy. What is metallurgy? The technique or science of working, heating the metals to give them certain desired shapes or properties. It is also the technique or science of making and compounding the alloys. The technique or science of separating metals from their ores. So these are different areas of metallurgy. So the various processes involved in the extraction of metals from their respective ores are called metallurgy. There are about 118 different elements known to us today. These elements are widely distributed on the Earth's crust in free state as well as in the combined form. Now this chart provides the approximate relative abundance of some elements in the Earth's crust. So these elements are generally classified into two main parts. One is metal, another is non-metal based on their property. So what are the metals? Metals are the elements which can be drawn into sheets or pulled into wires, which have high densities, high melting point and boiling point. Also they have high tensile strength, as well as these are very good conductor of electricity. Copper was the first metal which was used by man for making utensils, weapons, and there are various purposes. Now during the chemical reactions, metal can form positive ions by losing electrons. Now metals, so you can say the metals are the elements except hydrogen which form positive ions by losing electrons or donating electrons. So this you have already discussed in the chapter of periodic table several times. Now gold, silver, copper, lead, iron, tin, antimony, mercury, these are also known from ancient times. Mercury is also earlier known as quicksilver. Now these metals are having usually 1, 2 or 3 electrons in the outermost shell and ionize by giving out the electrons. So these are known as electropositive elements because these can form the positive ions by losing electrons. All metals are solid except the mercury, which is the liquid metal. These are having various industrial applications, generally as catalyst, also essential in some biological processes. Iron is a constituent of hemoglobin, magnesium is the constituent of chlorophyll. So these metals are very important part for national economy. Most abundant metal in the Earth's crust is aluminium. Major metals in the Earth's crust in the decreasing order of their abundance are aluminium, then iron, then calcium, sodium, potassium and magnesium. Now come to the non-metals. These are the elements which do not conduct electricity, they are not malleable or ductile, they are generally brittle. During chemical reaction, non-metals form the negative ions or anions by gaining electrons. So we can say the non-metals are elements which form negative ions by accepting or gaining electrons. Hydrogen here is the exception. It is a non-metal which loses electron to form the positive ion. Now these non-metals are generally having 4, 5, 6 or 7 electrons in their outermost shell. These are small in number compared to metals, but they play a very important role in our daily life. Like carbon is one of the most important non-metal which is responsible for our life on this earth. Carbon compounds like protein, fats, carbohydrates, vitamins, enzymes, these are very essential for growth and development of the living organism. Most abundant non-metal in the Earth's crust is oxygen. Major non-metal in the Earth's crust is in the decreasing order of abundance are oxygen, silicon, phosphorus and sulfur. Even though there are smaller number of non-metal, they are the main constituents of earth, air and ocean. Like oxygen and nitrogen are the main constituents of air, oxygen and silicon are main constituents of earth, and hydrogen and oxygen are the main constituents of oceans. You know that all metallic elements except mercury are solids. Some non-metals are gases, one is liquid, and remaining non-metals are solid. Astatine, which is the bottom element of the halogen group, it is the rarest naturally occurring element. There are certain elements also available which are showing the properties of both metals and non-metals, and these are called semi-metals or metalloids. And these are boron, silicon, germanium, arsenic, antimony, tellurium and polonium. This part we have already discussed, that these are some metals are less reactive. They do not react under normal conditions with oxygen, water, carbon dioxide or some reagent. These are also called noble metals, and these are generally less reactive metal. Those are mostly gold and platinum, and they occur generally in the native state. There are some metals which are most reactive, and so these are present in the combined state in the form of generally oxide, carbonate, halide, sulfide, sulfate, etc. And these are mixed with mud, clay, sand and stone. Example like sodium and potassium, these are very reactive metals. They occur mainly as their chlorides. Calcium and magnesium, they occur as mostly carbonates. Aluminium as its oxide, while zinc, lead, copper, mercury and silver are found as sulfides. Now we have already discussed the reactivity series in the electrolysis chapter. In this reactivity series, the metals in the decreasing order of electropositivity is placed. So it might be expected that those at the top would combine with more electronegative elements in their minerals. So these are certain metals and their main ores. Like potassium, main ore is carnallite. Sodium, it is rock salt. Calcium, it is limestone or marble and gypsum. Magnesium, it is magnesite and kernelite. Aluminium, generally bauxite, cryolite, feldspar and mica. Zinc, it is zinc blende and calamine. Iron, it is red hematite and brown hematite. Lead, it is galena. Copper, copper pyrites. Mercury, it is cinnabar. Silver, it is argentite and horn silver. Now there are some insoluble ores are found as rocks, while soluble ores like alkali chloride are washed away by the rains and generally found in the sea water. Main ore of aluminium is bauxite. Now from bauxite, aluminium is extracted. So for aluminium, the different main ores are, first is bauxite, then it is cryolite, then corundum. Corundum is anhydrous aluminium oxide. Iron's case, the main ore is hematite. It is generally extracted from the chief ore hematite. Hematite we have two types, one is red hematite and brown hematite. Other than hematite, iron has other three ores mostly abundant: magnetite, iron pyrites and siderite. And main ore of the zinc is zinc blende, from which zinc is extracted. Other than zinc blende, we have zincite and calamine. These are the list of some more ores mentioned over here. Thank you for patient hearing.